In this presentation, I'll be explaining solar radiation measurement methods and the instrument used for that solar radiation measurement. This is the part 1 and part 2 will be another presentation. Now let us see solar radiation. Solar radiation is the sum of beam radiation, that's called the direct radiation, and diffuse radiation. For direct radiation plus diffuse radiation, we call it as total solar radiation. Beam radiation, that's called the direct radiation, that is the sun radiation is coming directly to that one. That's called the direct radiation that reaches directly to the Earth's surface, which produces the shadow effect. And the second one we call it as diffuse radiation. The diffuse radiation that is solar radiation from the sun after its direction has been changed. It's called diffuse radiation. And the variation in solar radiation, that is because of the process what we call it as reflection, absorption, and scattering. Now let us look into reflection, absorption, and scattering. Reflection means by the surface or the clouds. That is, for example, this is by surface. Even the clouds also getting, that is called reflected. So reflection will be either by the surface or cloud. Second one, absorption, short wave ultraviolet rays by ozone, and long wave infrared by carbon dioxide and moisture in the atmosphere. That is absorption of the solar radiation. The third one is called the scattering. Scattering means as solar radiation passes through the Earth atmosphere, the components of the atmosphere such as water vapor, dust in the atmosphere causes scattering one. Therefore, this reflection, absorption, and scattering that leads to the slight reduction in the solar radiation reaching on the Earth's surface. Next, we'll see that solar radiation measurement methods as such, instrument as such. For the solar energy data base at different location is very important to select the suitable location for setting up of solar plant. Based upon the solar radiation information or database, the solar plants are installed. Therefore, that is very important. And in order to measure this solar radiation, there are basically two instruments are using, but methods are there. One we call it as pyranometer. Second one we call it as pyrheliometer. In this presentation, I'll be explaining regarding pyranometer type of solar radiation measurement. Measurement of solar radiation data using pyranometer. This is a picture of a pyranometer. And this instrument measures the total radiation arriving from all the directions. That is, this dome-based structure can pass all the radiation in all the directions from the solar radiations. That can pass direct as well as diffuse components of radiation can be passed through this dome-based structure as such. Therefore, it measures all the radiation that is of the potential used to the solar energy collecting system. Therefore, a thermopile type black and white pyranometer is shown here. The most important part of a pyranometer is the detector that responds to the incoming radiation. And the most accurate detectors uses stack of thermocouple that we call it as thermopile to measure how much hotter a black surface becomes when exposed to sunlight related to the white surface. When solar radiations are exposed to the black surface, that absorbs the radiation and the temperature rises, and how much is the temperature rise related to the white surface, that is measured using thermocouple, and a set of thermocouple we use as thermopile. Therefore, that is the detector used in a pyranometer. Continuing the pyranometer. Pyranometer is a device that measures solar irradiance from a hemispherical field of view incident on the flat surface. Like this one, it's a pyranometer. All the radiations falling on this hemispherical dome-based structure, it can be measured that all the radiation, and that is beam radiation or direct radiation plus diffuse radiation can be measured by pyranometer. Or pyranometer measures the global irradiance. That means that beam radiation plus or direct radiation plus diffuse radiation that can be measured by using pyranometer. And here the global irradiance may vary greatly depending upon the height of the sun in the sky and thus location of the earth, time of the day, time of the year, and on meteorological and environmental factors such as cloud, aerosols, smog, fog, precipitation, and others. All these factors will be affecting the global irradiance. For the global irradiance, we will be measuring direct radiation and diffuse radiation. To measure that one, the arrangement at the top is like this one. Here the detector element is a thermopile, a set of thermocouple, and that is falling on this one. Temperature, there's a black body setup is the temperature increases, that is measured using a thermopile setup. Therefore, that voltage or the EMF produced in that one will be proportional to the temperature rise, which is proportional to the this radiation falling on this one. That is global irradiance. Therefore, this is just a pictorial as we already see. This is the direct beam, this is the reflected beam, and this is a diffused beam that is falling on the earth. Coming to the principle of pyranometer. Pyranometer basing detector is a thermocouple. There are two junctions of the thermocouple. This is a hot junction and this is a cold junction. This hot junction is actually, it is heated by using the solar radiation. And this is the reference junction. Therefore, pyranometer uses a thermopile for measurement of temperature due to the radiation. Thermopile means a set of thermocouple joined together. We call it as stack of thermocouple joined together is called thermopile. Therefore, the hot junction of the thermopile is connected to the black surface on which the solar radiation receives. To the black surface where the solar radiation receives, temperature rises. That is the hot junction of the thermocouple. And the cold junction will be connected to the surface that does not receive the solar radiation. That does not receive the solar radiation. Due to the difference in temperature of the hot junction and cold junction, there will be an EMF will be generated that is proportional to the difference in temperature and which is proportional to the solar radiation. Therefore, the voltage that is or EMF produced in the thermopile or thermocouple as such, that is proportional to the temperature difference of hot junction and the cold junction, which is proportional to the solar radiation falling on the black body or black surface as such. This is the thermopile structure in which a lot of, number of thermocouples are joined together in order to increase the output voltage. Coming to the construction of pyranometer, outer dome made from a hemisphere of optical quality glass. That is this one, outer frame, number one. This is frame a quality glass so that sunlight can be, that can be reached to the black body or black surface. There it can be reached to this directly. It can pass through that transparent one. An inner dome made from a smaller hemisphere of the optical glass. That is inner frame, this one. And black carbon disc, that is this one. Black carbon disc that is being illuminated by the sun radiation that absorbs broad range of wavelength of the solar radiation and acts as a sensing element. This acts as a sensing element that is to which that solar radiation falls that one. And another disc is there that we call it as control disc that is not illuminated by the sun or that acts as a compensation and compensating element. Therefore, this is actually, it is a cold junction and this is a hot junction. A voltage will be developed between this one thermocouple or thermopile as such. A voltage will be developed proportional to a difference in temperature or the radiation falling on this one. Therefore, any source of, why we are calling this a compensation, disk as such, here any source of temperature rise rather than solar heat, that is from acts as a noise as such, we can consider that. Any noise comes here, that will be affecting both that one, that gets cancelled. Therefore, perhaps the air conditioning unit positioned nearby will warm with that will be warming both the disk, therefore that equally get cancelled. This is a reference surface and this is the black surface on which the radiation is falling. And so the difference between the two disks, that is black surface on which the solar radiation is falling and here the reference surface, and the difference in between the two discs and the temperature what we are measuring is caused by the sun. That the difference in temperature or that corresponding voltage, that is because of the radiation falling or passing through this one. Continuing the construction of pyranometer, the thermopile temperature sensors compares the temperature rise of the two discs. These two discs, the difference in temperature causes a voltage that proportional to, of course, difference in temperature that proportional to the radiation falling on that black surface. And output lead, usually about 10 meter to 300 feet, that is the output lead voltage sensing one. And replaceable silica gel, that is replaceable silica gel cartridge absorbs moisture to prevent the dew forming inside the cold nights, that is absorbing that one dew. Then adjustable screw legs let you level the pyranometer using its built-in high precision spirit level to make it same level, that is screw mechanism is there. Here adjustable screw legs are there. Now let us see the working of pyranometer. It's a thermoelectric effect. The basic concept is thermoelectric effect. The dome on the pyranometer acts as a filter that transmits the solar radiation with a wavelength from 300 nanometer to about 3 micrometer, but blocks thermal radiation with a wavelength longer than 3 micrometer. That is this dome. And the filtered radiation, is absorbed by the black surface, that is absorbed by this black surface on the pyranometer and converted into heat. That will be converted, temperature rise happens once radiation falling on the black surface. And the temperature gradient of the black surface through the thermopile to the pyranometer body, which acts as a heat sink. A temperature difference happens here, and that is measured using a thermocouple or group of thermocouple or stack of thermocouple, that's thermopile. Continuing the working of a pyranometer, each thermopile will generate a voltage proportional to the temperature difference between the black surface and the body. This body means this one, between this one, depending upon the temperature difference, a voltage will be or developed, or that will be generated. The output signal from the pyranometer can either be output voltage from the thermopile or the pyranometer can include electronic and converts this signal from the thermopile into more convenient output signal. It can be converted into more convenient. Anyway, you will be getting a voltage that can be converted further by either it can be converted into a digital form and that can be transmitted or that can be displayed that way. Now let us see what are the types of pyranometers. Pyranometer measures the total or hemispherical or global radiation over a hemispherical point of view. That is hemispherical, all the radiation falling on this one can be measured. Therefore, that includes, as I told you, direct radiation or beam radiation plus diffusion radiation. Therefore, the hot and cold junction of the thermopile and EMF proportional to the solar radiation that is received, that ranges from that 0 to 10 millivolt. And the different types are that epipyranometer, yellow solarimeter or photovoltaic solar cell, thermoelectric pyranometer, and Mol-Gorskiy solarimeter. Here we'll be concentrating these two types of epipyranometer and yellow solarimeter, that is photovoltaic based cell. This will be explaining in the next slides. Coming to the epipyranometer, the temperature is sensed on the concentric silver ring, 0.25 millimeter thick, consists of black, that's absorption radiation, and white surface, that is reflect radiation with the thermopile. Here, the structure here, we can see that one, there will be different sectors, divided into different sectors. This is black, this is white region, this is a black region. And this type of ring is kept below this one. So that here, when falling this one, the radiation will be absorbed by the black region and the temperature rises here. And here the radiation passes through the white region. Therefore, there will be a temperature difference between the black region of the black sector and the white sector. That temperature difference is measured using a thermocouple. That's the one method as such. Therefore, 10 or 15 thermocouple junction is direct the temperature difference between coated rings, and it is enclosed in a hemispherical glass ring. In this one, it is kept below this one. And alternate black and white surface, that is temperature difference between the black and white surface, is measured using thermopile. That is, here this is kept below this one, and the temperature difference between black and white region or that surfaces we are measuring using a thermocouple or set of thermocouple, that's called thermopile. Another alternate method is that is rather than a sector division, here this will be alternate black and white rings as such. For alternately concentric black and white rings to measure the radiation. That's another arrangement in which will be alternate dark and white rings as there. Therefore, the dark or black ring will be getting heated, and here it is not getting heated because radiation passes through that one. Here the radiation is being absorbed, and the difference in temperature is measured using a thermocouple. Therefore, that's another arrangement, not like this one. That is sector, it is divided as a concentric circle with a black ring as well as white ring. The second one is the pyranometer is called yellow solarimeter. That uses photovoltaic detectors. That is, silicon cells are used to measure the solar radiations. And the incident radiations are converted into equivalent electrical energy by the photovoltaic cells. For photovoltaic cells are used, as a radiation falls on that one, there will be a current that indicates the radiation, or that can be calibrated in terms of the radiation. One problem as I can say that when it's not linear. That is that's called the spectral response. Spectral response means that current generated by the solar cell divided by solar power incident. That is not, that's not linear as such. The sense, as solar power increasing, the current is not increasing linearly. So that relation is not linear. That's called spectral response is not linear in this case. Therefore, as we can see that one equivalent circuit of a PV cell, as you know that this is already explained previously, that introduction of solar cell as such. Here, as solar radiation changes, this current generated by the solar cell changes, radiation changes, and of course this is the practical circuit, a series resistance, shunt resistance, as well as a diode is there. Therefore, what is the current output is this one, and if you plot the current versus the voltage, VI characteristics of a solar cell as irradiation varies, that changes that VI characteristic, or this is called the short circuit current, this is called the open circuit voltage, and this short circuit current change as a radiation change, that is not, of course, linear as such. That is why spectral response is not linear. In this one, the solar radiation, that is measured by measuring what is the solar cell current as such. Therefore, that current is not linear to the solar power incident on that solar radiation incident. That one, that is the second one, that is called yellow solarimeter. That is using basically a photovoltaic cell is using to sense the radiation. Pyranometer can be used for different applications like in weather and climate studies, to monitor the performance of photovoltaic power plants by comparing the actual power output from the PV power plant to the expected output based on the pyranometer reading, and efficiency of the PV power plant can be determined. To determine the suitability of the potential sites for PV power plants, that can be located by using, measuring the solar radiation by pyranometer. And building automation also pyranometer is using, and agriculture purpose also pyranometer using. Therefore, there are different applications for the solar radiation measurement instrument like pyranometer. There is a modified pyranometer that we call it as shaded pyranometer, that measures diffuse radiation only. That direct radiation does not measure. That measures only diffuse radiation. Therefore, that is providing a shielding like this one. Therefore, the shield ring or shaded, or it's called a shaded ring, like shaded ring is provided. The shaded ring will provide direct radiation from reaching the pyranometer, or that shaded ring prevents direct radiations from reaching the pyranometer from the sunrise to the sunset. so that the shaded pyranometer measures diffuse radiation only. That is, shaded pyranometer measures only the diffuse radiation that prevents or that blocks the direct radiation. In part 2 presentation, I'll be explaining pyranometer to measure direct radiation.